Good morning, students. Chapter 3, Motion in Straight Line. In last week, we have studied about what is motion, what is concept of particle, frame of reference, position, path length, displacement, some questions based on it, average speed, average velocity, instantaneous velocity, again question based on that. Okay. Now, for motion, graph is one of the most powerful tool to understand motion or to represent any motion. How to represent motion as a graph? Okay, so see, here we will study about xt graph. X means position and t is time. Okay, xt graph. What is position, time, xt graphs for motion? Yes, in board exams as well as for JEE and NEET, these graphical questions are important. Okay, there is one section in which only graphical questions are asked. So, make a note about this graphical question. Position, time, xt graph for motion. See, first of all, how to draw any graph. Okay, for motion along a straight line, say x coordinate varies with time, and we have xt graph. How to draw any graph? First of all, you have to observe motion. Okay, if you want to study any object, for example me, so right now, see, as time is varying, t is equal to 0 second, 1 second, 2 second, 3 second, 4 second, but my position remains same. I am here, I am here. I am not changing my position. I am not changing my position. If from this corner I am at 5 meter distance, then yes, at time t is equal to 0. What is my position? 5 meter. At time t is equal to 1 second, what is my position? 5 meter. At time t is equal to 3 second, what is my position? 5 meter. So, if I am not changing my position, okay, then I am in rest condition, then what is graph? If I am changing my position, then how to draw a graph? We will see in this topic. Okay, but for this topic, we have to remember one equation. See, the slope is equal to delta x upon delta t is equal to tan theta of the graph. Gives the average velocity of an object for a given time interval. Now, what is slope? See, we will understand one by one. Okay, see this first graph, xt graph, where t axis and here it is x, position axis, time axis, position axis. These two axes are perpendicular to each other. Okay, now object is at rest. How you can say from this graph that object is equal to rest? See, if it is x0, okay, for example 5 meter, okay, at time t is equal to 0 second, what is position? x0. At time t is equal to 1 second, what is position? 5 meter. At time t is equal to 2 second, what is position? 5 meter. At time t is equal to 3 second, 4 second, 5 second, what is position? Yes, it is 5 meter. So if time changes but position remains the same, okay, from this graph we can say its position remains same, then object is said to be in rest condition. Object is said to be in rest condition. Okay, and for this graph, xt graph is parallel to time axis. It is time axis and this xt graph is parallel to time axis. So what is its slope? 0. How 0? What is meaning of slope? See, slope means if any plane makes some angle with horizontal. For example, if my hand is like this, then it is parallel to x-axis, horizontal, then slope is 0. But if I incline my hand like this, means it makes some angle with this horizontal, okay, means it has some slope. It has some slope. Okay, what is slope? Okay, now xt graph is parallel to time axis. Slope is 0. So if slope is 0, then its average velocity is also 0 because angle made with this time axis is 0. Angle made with this time axis is 0. Okay, so it is first point. If object is at rest, xt graph is parallel to time axis, slope is 0, velocity is 0, and angle theta is equal to 0. You have to remember this each and every point. You have to remember this each and every point. Again, understand what is meaning of slope. If it is horizontal line, if a line makes some angle with this horizontal, okay, for example it is angle theta, then yes, it has some slope. It has some slope. Okay, okay. First point. Now second point. What is second point? If an object moving in a straight line covers equal distance in equal time interval, it is said to be in uniform motion, means constant velocity. See, for example, if at time t is equal to 0, position is 5 meter. At time t is equal to 1 second, position is 10 meter. At time t is equal to 2 seconds, position is 15 meter. At time t is equal to 3 seconds, position is 20 meter. Then see this first second. What is distance traveled in this first second? 5 meter. During t is equal to 1 to t is equal to 2. What is distance traveled? Again 5 meter. During t is equal to 2 to t is equal to 3. What is distance traveled? Again 5 meter. Clear? So, if an object moving in a straight line covers equal distance in equal time interval, it is said to be in uniform motion, means constant velocity. Hello student, you know how to find average velocity? Average velocity means displacement upon time. See, for first this time interval, if you find average velocity, 10 minus 5 upon 1 minus 0, your answer is 5. Yes. For any time interval, if you find average velocity, its answer will be same. See, for example, for this t is equal to 2 to t is equal to 3. What is displacement? 20 minus 15. So your answer is 5. Divided by 3 minus 2, 1. Clear? Hello? If you take t is equal to 1 to t is equal to 3, t is equal to 1 to t is equal to 3, then what is displacement? 20 minus 10 divided by 3 minus 1 is equal to 10 upon 2, 5. Okay, so if object covers equal distance in equal time interval, it is said to be in uniform motion. And what is meaning of uniform motion? Its velocity remains constant. Its velocity remains constant. Okay, and for such motion, xt graph is a straight line. Xt graph is a straight line. Yes, here we have two cases for uniform motion. For uniform motion, we have two cases, figure 1 and figure 2. See, in this figure, as object is moving in positive x direction. How you can say object is moving in positive x direction? Because see, at time t is equal to 0, its position is x0. As time increases, its position also increases. So we can say object is moving in positive x direction. So as this graph is in upward direction, its slope is positive. Slope is positive means its average velocity is also positive. Okay, and for second graph, see, at time t is equal to 0, its position is here, x0. As time increases, its position decreases. It means it is moving in negative x direction, and as this graph is moving in downward direction, its slope is negative. Its slope is negative. So its average velocity is also negative. So for uniform motion, you have two cases. First, second. In this case, object is moving in positive x direction, slope is positive, average velocity is positive. In this case, object is moving in negative x direction, slope is negative, and average velocity is also negative. So see, from graph you can say these all points. If graph is in upward direction, its velocity is positive because its slope is positive. Okay, and similarly for this case. Now, see, here, for each and every time interval, if you find average velocity, you will get your answer 5 meter per second. For this each and every time interval, if you find average velocity, you will get answer 5 meter per second. So remember one of the most important point for uniform motion, velocity, instantaneous velocity is same as average velocity at all instants. At time t is equal to 0, 1, 2, 3, 4, 5, 6, 7. At any time, velocity is same and is equal to average velocity. Clear? So you have to remember this point. Now if, last case, now if I say distances traveled in equal time interval are different. For example, at time t is equal to 0, position is 5 meter. At time t is equal to 1, position is 10 meter. At time t is equal to 2, position is 17 meter. At time t is equal to 3, position is 20 meter. So now see, in equal time interval, distances traveled are not the same. During this first second, what is distance traveled? 5 meter. During this second, what is distance traveled? 7 meter. And during this third second, what is distance traveled? 3 meter. So if you find average velocity for this time period, for this time period, for this time period, your answer will be different, not 5. Your answer will be different, not 5. So such a motion in which the average velocity is not constant is called non-uniform motion. Is called non-uniform motion. An xt graph is a curve instead of straight line. Xt graph is a curve instead of straight line. Okay, and it is said to be non-uniform motion of object. And in this case, see, if you find average velocity for each and every case, velocity is not constant, it is changing continuously, and that's why it is called accelerated motion. That's why it is called accelerated motion. So it is one topic, xt graph for motion. See, this graph, first graph explained was for rest, means stationary object. These two graphs are for uniform motion and this graph is for non-uniform motion. Remember, uniform motion means velocity constant. Non-uniform motion means velocity is not constant. Clear? Okay. Now, velocity changes. Then it is called accelerated motion. So, what is acceleration? Okay, that we will discuss in next lecture. See. Okay, now see, for uniform motion, velocity remains constant, means there is no change in velocity. But as discussed in last point, for non-uniform motion, velocity is not constant. So if velocity changes, then what is rate of this change in velocity? See, rate of change in velocity is known as acceleration. Now, we have defined average velocity. Okay, how to define average velocity? Rate of change of position is called average velocity. If you compare this definition, how to write definition of average acceleration? Average acceleration is rate of change in velocity. Average acceleration is defined as rate of change in average velocity. See, rate of change in velocity is known as acceleration. The average acceleration A bar over a time interval is defined as change in velocity divided by time. For example, at time t1, velocity of object is v1, and at time t2, velocity of object is v2. Then average acceleration A bar or A is equal to delta V upon delta T, means V2 minus V1, final velocity minus initial velocity upon time interval. To see, this equation is similar to equation of average velocity. V bar is equal to delta x upon delta T is equal to x2 minus x1 upon T2 minus T1. Yes, similar, see, A bar is equal to delta V upon delta T is equal to V2 minus V1 upon T2 minus T1. Clear? Now, what is SI unit? See, acceleration is equal to change in velocity upon time. What is unit of velocity? Meter per second. What is unit of time? Second. Okay, so what is unit of acceleration? It is meter per second square. It is meter per second square. Remember this unit. Now, see, we have defined first quantity called displacement. It is vector quantity. It may be positive, negative or zero. From displacement we have defined velocity. Velocity is also vector quantity. It may be positive, negative or zero. And now here we have defined acceleration from velocity. So yes students, if velocity is vector quantity, acceleration is also vector quantity. Acceleration is also vector quantity. See, we have solved some examples. If displacement is positive, average velocity is positive. If displacement is negative, average velocity is negative. Means velocity is in direction of displacement, change in position. Velocity is in direction of change in position. Similarly, acceleration is in direction of change in velocity. This direction of acceleration is in direction of change in velocity. You have to remember this point. Direction of acceleration is in direction of change in velocity. A is in direction of delta V. If delta V, change in velocity is positive, acceleration is positive. If change in velocity is negative, acceleration is negative. And if velocity does not change, velocity is constant, uniform motion, then acceleration will be zero. Then acceleration will be zero. Okay, so it is equation of average acceleration. Again, average value, it gives value over a period, not at any time. Then how to find acceleration at a time? Yes, you know its concept, instantaneous acceleration. Instantaneous acceleration defined as same way as the instantaneous velocity. I said you, okay, we will directly remember concept of instantaneous acceleration. Instantaneous acceleration at time t, A is equal to limit delta t tends to 0, delta v upon delta t. So A is equal to dv upon dt. Okay, remember theory of instantaneous velocity. A is equal to dv upon dt, where what is this term? It is differentiation of velocity with respect to time. Differentiation of velocity with respect to time. Okay, you have to remember 3 points. First, if dv upon dt is positive, then acceleration is positive. If dv upon dt is negative, then acceleration is negative. And if v is constant means which type of motion? Uniform motion. Then acceleration is 0. See, this each and every statement is one MCQ or one point to be remembered. Okay, if for velocity constant, which type of motion is? It is called uniform motion, and for such uniform motion acceleration is 0. Now see, you have to remember some mathematical points. Okay, acceleration is dv upon dt, but we also know that v, that is velocity, is equal to dx upon dt. So now how to write? See, A is equal to d upon dt. What is value of v? Dx upon dt. And it is called A is equal to d square x upon dt square. Second order derivation. Second order derivation. How you can say it is second order derivation? Because it is d square x upon dt square. See how to remember. D square x means second order derivation of x position with respect to time, and it is also denoted by x two dots. Clear? So it is acceleration. So from we can say second derivative of position with respect to time is called acceleration. So we can define acceleration with the help of two equations. Derivation of velocity with respect to time, it is acceleration, and second order derivation of position with respect to time, it is also called acceleration. Clear? Okay. Now see, these are relations from position to velocity to acceleration. Now with the help of one example, we will understand, okay, if you are given position, then how to find velocity and acceleration. See, position of particle x is equal to 3d square plus 2t plus 1. Find velocity and acceleration. See, you are given position x is equal to 3t square plus 2t plus 1. Velocity, how to find velocity? You know, v is equal to dx upon dt is equal to, see, it is x, differentiation of 3t square. What is differentiation of 3t square? 60. Yes, very good. What is differentiation of 2t? Only 2. And what is differentiation of 1? 0. Clear? You know what is differentiation. If you have any doubt in differentiation, make sure. Okay. Then what is v? V is equal to, it is 60 plus 2. See, it is equation of velocity. V is equal to 60 plus 2. T time. Yes, we know that. Here V is not constant. It is varying. It is varying. As T is changed, velocity is also changed. Okay. So how to find acceleration from? See, what is equation of acceleration? A is equal to dv upon dt. And what is V? Yes, here it is. V is equal to 60 plus 2. So if you differentiate this velocity, see, d upon dt, what is V? It is 60 plus 2. Now differentiate this. Okay, what is differentiation of 60? It is 6 plus 2 is 0. Means acceleration A is equal to 6 meter per second square. So it is how you can find velocity, and from velocity you can find acceleration. From velocity you can find acceleration. See, remember, if you are given position, if you derivate first time, you will get velocity. If you derivate second time, you will get acceleration. That's why second derivative of position with respect to time is called acceleration. Clear? How to find velocity and acceleration from position? Derivation. Okay? Pause your video, write down from board, make notes and send notes on my WhatsApp number.